Hi, in this video I'm going to show you how to write plugins for Ocelescope. As an example, we will use the object-centric inductive miner implemented by Niklas van Detten, which you can find under this repository over here. To first start off, let's look how the plugin should look like. So first of all, you have this box over here with a title, a version, and a description. When clicking on View Plugin, you have this method over here with a title and a description. And when you run the method, you can select an event log. And after submitting, you get a process tree which you can inspect and also interact with. Now, for any plugin you develop, it's important to know what is the input and also how should the output look like. In the case of the object-centric inductive miner, I went through all these files over here and looked for indicators of the input and output, which I found in this init file over here under the apply function. We can already see that the input is an object-centric event log, and the output is a process tree, which is recursively defined as operator nodes and if nodes. For our plugin, this means that we want the user to select an event log, and the output is a process tree, which is represented as a graph. Okay, now that we know the input and output, we can start with the plugin development itself. For that, we want to use this plugin template, which is provided by this repository. And I'm going to walk you through how to set this template up. So first of all, you want to clone the repository. And then install all the dependencies with UV-Sync. You can then activate your virtual environment. And do Ocelescope build, which builds the plugin so you can upload it onto the web application. You can see it was successful, and then we can upload it, which should look like this. Okay, the template itself comes with two files. The plugin.py file comes with three different classes. The first class inherits from the plugin class with a label, a description, and a version. You can already see that this corresponds to this object over here. And the method is defined in this block down here. So you can see the label and the description, which corresponds to this block over here. You can see that the user can select an event log, and after submitting, you get some kind of output, which is blank in this case. The inputs are handled in this function over here as parameters. So you can see you have a parameter for the event log that the user selects. And you can have additional inputs. For example, if you want the user to select object types, you can create this input class over here, which inherits from plugin input, and define the input in here. So for example, if I want the user to select object types, I can do it like this. So we also want to have also field over here, and we're going to see how this looks like at the end. Now the output is defined as a class which inherits from the resource class. The resource class is an object-based class for our output. And what's important over here is that it has a visualize function. This is basically what the user sees at the end, so what is displayed over here. So in our case, since the visualize function is empty, we also get an empty output. Now, if we want to have a second box over here with another method with some kind of other functionalities, we can do it by defining another plugin method. So for example, over here you have a different label, a different description, and a different function. So let's see how this looks like. You have to obviously do Ocelescope build to build the plugin. Exactly. So you have two boxes over here now, and over here you can see the drop-down menu where the user can select object types. Okay, now for our object-centric inductive miner, this means that we want to have some kind of plugin class with a method where the user can select an event log, and we return a process tree with a visualize function which returns a graph. Okay, now let's see how we can turn the object-centric inductive miner into a plugin. So the first step is to copy the most important files from the object-centric inductive miner into our plugin in a separate folder. So for example, util. And you can leave out some files, for example, example log or evaluation util, because they are not important for the algorithm itself. The second step is to build a bridge between our output and the output of the object-centric inductive miner, which is the process tree. As I told you before, we want our output to be a class which inherits from the resource class. So what is done over here. And we also want to have a visualize function which returns a graph. So over here we store all the nodes, all the edges, we collect all the object types, and we generate a color map so that different nodes have different colors. And we call a big graph function, which is basically turning our process tree into a graph object. And at the end, we return our graph with all its nodes and edges and some layout configurations. The graph class itself is defined in Ocelescope. So you can see it over here. You have the nodes, the edges, and the layout configuration. Okay, that's it for the output. Now we also have to build a bridge between the inputs. Because over here, we can see that the input is a TM4Pi Ocel class. But in Ocelescope, we have our own Ocel class, which is why we have to convert it over here. The rest stays pretty much the same, so we call the object-centric inductive miner just as over here, and we return our process tree. The last step is now to create our plugin class with the label, description, and the version, and a method. So we can see the method takes a object-centric event log selected by the user, and we return a process tree, which is obtained by calling this apply object-centric inductive miner function. Now, this would result in this plugin over here, which we saw at the beginning, where the user can select an event log and then get a process tree. And this is pretty much it, how to turn the object-centric inductive miner into a plugin. So for your interest, I also created this document over here, which summarizes the most important points. And yeah, that's basically much it, how to write plugins for Ocelescope. Thank you for watching.